Today we are going to talk about the administration. So after we finish today's lecture, you should be able to understand how to install, how to configure, finally how to run and manage the Hadoop system. Okay. So then after we finish this one, so as a user we are going to build a real cluster. So far you have used the pseudo cluster, which means in one system, everything inside. Okay, it pretend a cluster. Okay, their language is the HDFS, their language is the MapReduce, but it's only running on one system. So you're given the virtual image, actually the pre-installed, the pre-configured everything. Actually, when you start up your virtual machine, Hadoop cluster is running on your system. Okay, so you don't know how it is and what's going on really, but after you finish this lecture, you should be able to install and configure your system. So today, especially in this class, we are going to use the Cloudera Hadoop version CDH, the 3.0 and 4.0. So Cloudera, actually the Hadoop is the has been developed under Apache Foundation. Anyone who never heard about what is Apache? You probably used Apache web server, right? Apache Foundation is an open source project. It's a big project. It's not only for just the web server. So they support the variety of the computer science project, including the Hadoop. So after the Google announced open their idea and the source code of the GFS and MapReduce, then they actually got the permission from the Apache Foundation. Under Apache Foundation, Hadoop is one of the projects. Okay, then some of the developer actually founded the company, the Cloudera, because many of the users, they want some guaranteed support, the customer service or the reliable system. Even though the Hadoop version from the Apache Foundation is working very well, sometimes there is a bug because it's open source, so nobody actually is responsible for that. Which means I'm running the very critical system. If this system fails, there might be huge amount of money loss. But who will be responsible for that? The user should be responsible, but we do not have such a skill or the experience. So the Cloudera was founded to support such a thing. So Cloudera has the version is for the CDH. So 3.0 right now, I think the 5.0 is announced, whatever. So we will see briefly about that. Even though Hadoop can run a single machine, as you are using on your virtual machine, but it's definitely not recommended and very limited. So definitely we need to build a cluster. Okay. So many people actually start from the small cluster to get the more experience, and also for your testing. So before you apply the MapReduce program and algorithm for the production system, for example, suppose that your production system is a 2,000 node and 100 petabyte size data. So when you run a job, it will take several days. And after a few days, you realize there is a problem and compile again running. So it takes some time. So it's a good idea that many people actually start from not even the 6 or 4 or 6. So in my case, I tested only 2. One is a master and another one is for the data node. Sometimes at the time I didn't have any data. I just used the sample data. At the time it works. So even you can try this kind of testing in your computer at home. So think about the example of this one. Data grow approximately 1 terabyte per week. 1 terabyte right now is not the big data, right? So think about the Facebook message or the Twitter and the launch of the social media data. Also, the enterprise level system, like any company. For example, when I work as a database administrator in a bank, so more than 15 years old, even at the time, I have had managed more than 100 servers. So every day, it's still 15 years ago, but 100 server in a bank, then each machine produce bunch of the log data. So it takes a day actually to check all the log data to generate it. So similarly, nowadays the network log, system log, database log, each and every application produce a bunch of log data, and so pretty much their total amount of size is bigger than 1 terabyte. Okay, so let's say there is 1 terabyte of data, and Hadoop can replicate at least three copies of the data. So you remember the concept of Hadoop. Hadoop has the 3 copies, as before the 3 copies of the block. So which means 3 terabyte per week. Okay, and also we need overhead. Usually, when we store the data, block-based system. So nowadays, most of the operating system, database system are block-based, which means, for example, in operating system, it's a 512 byte data. It's a data structure, so we can put the data based on such a block. Can we use the entire 512 byte of your data? Actually, no. Each block should have had information. Okay? So let's say roughly this is a 10%, 50 byte. So can we use a 462 byte for data?
No.
Actually, we can use, but it's not a good idea to fill up 100% of the data. Why?
Inner fragment.
From time to time, the data can be changed. For example, there is the UV inside, but I decided replaced by the University of Bridgeport. So do I need to change entire shift, right? It takes a time because it requires I/O. So if you do not have the space, you need to actually link to the free space. So when you read the data, how many I/O? 1, 2. So it's a waste of time. So to address this problem, you can leave some portion of the data as a free space for future use. Okay, then you can use this space for the replace. So this is almost all the system used such a. This is called the overhead. How many? It's 30%. Roughly, most of the system leave 30% of the space for future use. That is called the overhead. Specifically, the database actually you can specify such a free list how much you can use, you can leave for the free space. For example, as a default 40%, or 30%, 20%. If your system is read-only data, it can be just 5% for your sake. So you can actually configure such a overhead size, but most of the operating system probably not. It's already configured in the system. Yes.
This is considered like a waste of spaces. Hadoop doesn't only write once.
Yes. So at the time you don't have to worry about such a free space, but for your sake you can leave such a thing. So roughly, yes.
Is this packet? We talk about the packet.
Block. It's a block based.
So the block.
It's not only for the Hadoop, so any operating system or the database or it can be the network also. Okay? So we can say roughly such an overhead has a 30%, which means a week we need the 4 terabyte of the space. And how many weeks? 50 something. So usually 2 years of data, so 100 terabytes bigger and bigger. So we need to consider such a thing. Okay, such a amount of data to configure system. So we need the head of system. Why? Head of system is we can use the cheaper node and also we can add while the system is running and so on. There are benefits. Okay, so as we have learned the last few weeks, we can classify the node into two parts. One is the slave, another one is the master node. Okay, and also slave node works for data. Okay, data node. And also in terms of the data node is actually the daemon program. We already discussed about what is the daemon program. So once the head of system is starting up, then the head of HDF-based file system is mounted, and then the several process will be created. Such a process is called the daemon process. So we have the data node and the task tracker process, daemon process in the slave node. Data node is working for to store the data, while the task tracker is working for math reducer programming, especially mapper and reducer. Okay. Then the master node is the naming node, the naming node and secondary naming node. Secondary naming node can be separate node, and also as for the daemon program process, we have the job tracker. Job tracker is a coordinator for your math reduce programming. The job tracker can running on the same node as the naming node, but it is suggested if you have the big system, so you can separate the node for the only for job tracker because it's the kind of hub. Okay, so many clients will request a job through the job tracker. Yes.
Yeah, so in the pseudo machine, pseudo system, so can
Which
we-
system?
Pseudo system, so I mean,
Pseudo. That pseudo cluster includes everything in one machine, which means there may be several processes, including data node process, naming node process, secondary naming node process, and the task tracker, job tracker running on one machine.
so can we put all the master nodes in one pseudo machine? Also,
Yes, this node works for the master node as well as
slave.
slave node. Okay, naming node and the data node also.
How many slaves? No.
How many slave
Yeah,
nodes?
yeah, data nodes. Virtually, how many?
In the real
In the
cluster,
C- no,
virtually in this,
Yeah.
just one data node. It's a pseudo cluster. It's not real cluster. Okay, just one data node. Okay, in the real cluster, ideally there's no limitation. Okay, but sometimes it's limited by naming node. What is the main role of the naming node?
Control the job.
It keeps
Gives a log of the
all
job.
the data about data node.
Yeah, available
Keep
data.
the metadata,
Metadata.
which means, so if you have the unlimited, the number of the data node,
It will be
the master node should be unlimited. So there might be a limitation. In other words, we'd better have the better specification, higher specification of the computer for master node. Okay, more powerful. So this is the base configuration suggested by the Cloudera for the data node, slave node. So for example, for hard disk drive, at least several terabyte. Okay, JDOD is just a bunch of the disk. Which one is more important in data node? I/O or the CPU?
I think
CPU.
CPU?
Yeah,
No, no,
only
I don't
computation.
know.
It's I/O.
Right?
Because only read the
Yes, it's a data. Okay, it's a data node. But so far, many of the traditional parallel and distributed systems focus on CPU computation. However, in big data system, it's a bunch of the data, huge amount of data. In other words, it need bunch of I/O. So you better focus on the configuration, better configuration for how to handle such a I/O. Okay? Question? Okay. And regarding to the CPU, so it can be reasonable CPU. Reasonable CPU is enough. And however, you better have the bigger size of the memory. So actually, the head-up system used a lot of the memory resource. Think about the JVM. All the process are running on Java virtual machine. Each Java virtual machine requires measure the memory area. Okay, and also to speed up many of the data. For example, the master node keep all the metadata on the memory. Okay, and also at least the gigabit Ethernet. At least. Okay? Because they are communicating each other through the TCP/IP protocol. Okay, many of the traditional distributed or the parallel system MP, SMP is the symmetry is running on the one machine, but the multiple processor. But think about the MPP machine or other cluster, they are connected through the sometimes memory channel or fiber optic. Comparing to such a network environment, this is reasonable. Gigabit Ethernet is not very expensive right now. So I think the gigabit switch, A-port gigabit switch is around 100. Right? So you better use the gigabit Ethernet. 10 gig is recommended. Okay. However, 10 gig is expensive. If you cannot afford the 10 gig Ethernet, you better have the 2 times of gigabit Ethernet. Okay, so you can set up the 2 network. Okay, sometimes you can work further backup, and you can use this one for the higher bandwidth. Okay. Mostly it is unavailable. What is the rate? Backup. Redundant
Array.
array
Yeah.
or the inexpensive disk. Long time ago, when hard disk drive, it was very expensive. Probably I mentioned about the first storage box that we purchased, that I purchased, not me, my company purchased 20 years ago. At the time we purchased 64 gigabyte. Actually, it's a mirror, so only the 32 gigabyte. So from EMC, it's 3 times of, it's almost 300,000 bucks at the time. Only 32 gigabytes. When the hard disk drive was very expensive, so we cannot actually, what is the best way to back up the data? We can have mirror disk. Okay? When there is one data, you can just mirror, okay, as a backup. Which means when you have the 2 terabyte, the hard disk drive, 1 terabyte each, what is the utilization? You can use only 50% of the storage because you copy it, right? So, but because it's not very expensive, it doesn't matter if you need to purchase. However, long time ago it was very expensive, so 50% is not reasonable. So to address this problem, there is a different way, level of the rate. Okay, first one is the striping. Rate 0 is the striping. Striping means you can, instead of storing all the data in one disk, you can stripe along the disk. Okay, stripe. So what is the benefit of the? You can get the still 100% utilization, but the benefit of striping is what?
Speed.
You can access data
I see.
terribly. Okay, but still, if there's a problem on one disk, you may lose something.
This is the
It's a striking, rate 0. So this is called the rate 0, and rate 1 is this one, just a mirror. The benefit is the reliable. Even though one of them is crashed, still the other one we can replace and copy. Problem is 50%. So nowadays, most of the production system in the enterprise level company, they use both striping and the mirroring. It's called the rate 0 plus 1.
Or 1.
Okay? Then you can get the both benefit of this one and this one. However, there is more actually way to learn. 0, 1, 2, 3, 5, 6, 7, 8, something like that. And 5 was used a lot. 5 has the 80% of the utilization. Also, you can back up the data. You can, so but nowadays nobody uses because it's cheap. You can purchase that build the mirror. However, in Hadoop system, it's not recommended to build a rate, especially striping. It's not recommended. Okay? We will see one. Actually, we can get the benefit of the parallelism, parallel processing along the distributed block, distributed node, right? We don't have to waste the resource for this one. So it's not recommended. So you don't have to worry about that. So rate, forget about the rate in this, the Hadoop system. Okay? So you will have this is a simple idea. Multi-core, I think the dual core is enough for this one. But if you, okay. So, how much is that if you try to have such a several 4 terabyte hard disk drive and the multi-core, dual core, and the 8 gigabyte the memory computer, something around 1,000 to 1,500. Okay? I think the 1,500. So usually 2,000 bucks for each the data node is recommended. It's not expensive comparing the real cluster. So sometimes several millions of that, and their output is not better than such. So even though you have the 100 or 2,000, how much is that? Even it's less than 2,000, 200,000.
It's reasonable.
Yeah, reasonable. So we can save the money. Instead, we can buy one node and add it. It's not very difficult. And traditional, the distributed and parallel system or the cluster system, even though you have the more node, you cannot get the linearly improve the performance. Instead, it looks like this. So that was the problem. This one is more complex. Okay? So the more node you have, it's more complex, like the network conjunction and so on. But in Hadoop, ideally, it's linear. So sometimes there is more than several thousand nodes for one Hadoop system.
So, Professor, when adding nodes to a cluster, the performance actually goes down.
In traditional cluster
in
system,
traditional cluster.
yeah, sometimes it goes down. The performance goes down.
The communication,
yes.
Yeah.
For a little bit details about the CPU, the dual core is working well, and the quad core, yes, because nowadays even the personal computer uses quad core.
Yeah.
Anyone who has the laptop with the quad core?
Yeah.
Yes. So even the personal computer has the quad core. Hex core, sometimes somebody says just expensive and you cannot get the benefit of the hex core. Okay. Definitely hyper-threading should be enabled, or the AMT in the Intel. Okay. So as we discussed just before, it's not CPU bound, it's mostly I/O bound, and network. Network is also important. Okay. So in headed system, top range of top class of the CPU are not recommended. It's just expensive. If you have, if you can afford, it's okay, but otherwise you cannot get the benefit of such a top range of CPU. So quad core is no. Okay. And however, you'd better have the bigger size of the RAM, memory, okay? At least, for example, the math or reduced task, each task will take 1 to 2 gigabytes memory because it's running on based on the Java virtual machine, which means all the data will stored at the memory Java virtual machine. Okay. So it is, however, it is not just a single job machine. In one machine, there might be in one node or in your system, there might be several users and the several jobs are running on the same time. So you need to consider such a thing. So this is just a rule of thumb. The idea how to set up the task is the number of process core, okay, times the 1.5, which means if you have quad core, so you can run the 6 jobs at the same time. However, don't forget about the main purpose of the Hadoop system. It's not online transaction system. It's not the Google system. It's not the banking system. It's the batch job. Okay? So to analyze the big data, so 6 at the same time, simultaneously running the 6 job. Yes. However, you can even you can allow more than the 6 job or the more than such a recommended task. You can run that. How? At the time you can consider scheduling. As you have learned in your operating system class, probably you learned about the FIFO scheduler, priority scheduler, what else? Something scheduling. So you can consider such a scheduling algorithm, scheduling idea to learn more jobs running on the same machine. We will talk about that, and also it can be part of your midterm exam.
Okay, so I have a question. Like
Yes.
when you have a huge cluster that has like maybe thousands of nodes, would we possibly have more than one master node, right?
No. Master node, you can have only one master node, but you can back up the master node. You can have the copy of that because it's a single point of failure, but you cannot have the multiple. But this is possible. You have the master node, and for the data, for safe, you can have the
Secondly,
network mounting. You can mount this drive to the network, NFS, okay, something like that. But you have only one master node.
Only one.
Yes. So that is the reason for the master node.
Depends.
So you'd better have the bigger size of the master node. Spend more money for that.
I have read, Professor, that's the general guide for up to 30 nodes, you can have one master node.
Yes.
So we may have more than master nodes. If we have 60 nodes, for example, it's better to have 2 master nodes. Is that all?
At that time, when they use the 2 master node, it's not one like the 1 master node and master node 2. Logically, it's 1 master node. Okay, but physically they can separate. Okay, so but you should have the coordinator. Okay, so that is the reason you'd better have you'd better spending more money for the master node. It has been discussed how to back up or how to balance the workload of the master node, but I'm not sure the new version of the Hadoop system whether they support such a load balance or not. Okay, so then this is a memory. You should have the bigger size of the memory. For the disk, it's a bunch of disk for the data node. And how much what is the current speed of the hard disk drive? nowadays in your project hard disk drive? 7,000
Yeah.
mostly. So, but however, I think you can find the faster speed of the. So RPM is the rotation per minute, right? So you can find such a higher than 10,000 RPM, but this one is better even. Okay, when you have the faster and the bigger size one, because anyway, there's this is a hard disk drive. You have the spindle, rotate, and disk arm. Disk arm is moving forward and backward. Your data is located in one of the sectors. So you need two physical operations. One to find the data. So one is moving forward and backward physically. There is a header on top of this one, and this spindle should be rotating. So this is rotating. So rotate and moving forward and backward. So when you have the, even though you have the slower the spindle, but if you have the multiple disk arm, it will be faster to find the data. Okay, so you don't have to purchase such a, you don't have to waste your money to purchase the faster RPM.
It's a size. Just size.
I don't know why the practical maximum is a 24 terabyte for each node, but it is recommended. Okay? I think it's from the benchmarking
Yeah.
test.
In case if we use solid state process system.
I think so.
Same problem.
It's the same problem when you are using.
Solid state logic.
Yes.
So we don't have that mechanical.
I have no idea. But you can use the solid state disk for this one. I think so, but I don't know. There is a same problem. Okay, so that is.
So if you go back to this one. Yeah, so here, one particular maximum is 24 terabyte.
Yes.
Slave node, I mean
Yes.
that node, right?
Yeah, they are.
So what about the master? So there's any like recommendation for the master node?
Master node will be discussed later, but you should have the bigger size of memory. Okay, definitely, because you master node keep all the metadata on the memory for your speed, and also back up the data on the hard disk drive. So hard disk drive, it's a good idea to use the meter as well as the network mounting. So regarding to the rate, we already discussed about that. Okay. So we are using virtualization, but in real production is not recommended. Like, okay. I think we can understand.
Even in our project,
It doesn't matter. So you can use the the given virtual machine for your project, sudo or the real cluster, or if you can install by yourself. Okay. And Blade server is you probably see, if you never see such a website and Blade server, why don't you check the Google in google.com. It has something slot, so you can plug in the Blade server like that, but Blade server is not recommended. And one of the reasons is in case entire chassis is fake, it will run. Okay. And usually Blade server is not for I/O bound job, but it's for CPU bound. Okay. You can see the back is the blade is like that. This is one computer, one node. It has a limited local hard disk drive and the huge CPU or multi-core. Then they are connected using the network for SAN, storage area network. They share the chunk of the storage. This is a traditional system. So slave can be fake sometimes, is expected. However, based on the header architecture, it can be recovered. So we have at least 3 copies of the data. Once one of them is failed, we can actually restore from the other 2 available data. Okay? And also the job tracker and the naming node is checking the whether the data nodes are aligned, also whether each blocks are okay or not. So job tracker is automatically assigning the job for available on the available side and on the available blocks. So method node, as we have discussed many times, a single point of failure. So if you'd better have the very good computer for method node. So this is the recommendation. It's very high class. Computer is recommended, and definitely your power supply. So one is used for the backup, or the UPS system. UPS is not the main carrier. So unstop UPS is something power system. Unstoppable.
Yeah, so there is really good.
Unstoppable power system, something like that. Yes.
Uninterrupted force.
Yes. It's not the UPS carrier. Okay. You better have the UPS system. And the dual Ethernet card or the dual Ethernet network, not only for the wider bandwidth, but also can be used for the backup. And the hardware is, in this case, rated means it's a mirror and striking, especially for mirroring. At least 32 gigabyte memory size. So the next one is the network configuration. So at least the gigabit Ethernet. Okay, so 10 gig is recommended. If you cannot have the 10 gig because it's expensive, so you can have the dual, the gigabit Ethernet. Gigabit Ethernet is not very expensive. So you can have the gigabit Ethernet cable as well as the network adapter and the switch. When you build a real production system, you need to probably use the data center. Okay, data center. Even nowadays, most of the company has the backup data center. They are connected to the usually the fiber optics. Then like the U-verse, so fiber optics, and then even in one data center you have the rack, and each rack has the node. So we have discussed about the distance using the header system. Okay.
What do you call this system of your phone? What do you call this figure?
This one? This one? Fiber optics. Fiber optics.
Fiber optics.
Yes.
Okay.
Yeah, like Professor, Amazon have like huge data center.
Yes.
Huge.
Even Amazon and the Google data center, they use the, this is another story. One of the biggest problem of the building such a huge data center is power. Okay, the temperature. You need to maintain the temperature. So that's the reason many of the companies actually put their data center in the close to the North Pole. Really? Yes. Really. So Sweden or the Norway, that close to the North Pole, yeah, because to cooling down their system, it consumes a lot of energy. So they actually put their data center to the closely to the North Pole.
Maybe that's why the ice is melting now.
I think that's a different story.
Love world.
So far we have discussed about the hardware. Then the next topic is the software to build the Hadoop system. Hadoop consists of 2 parts. One is the HDFS file system. Another one is a map reduce system, which is application level, which means you should have the operating system. So header is running on the operating system. For example, when you launch the virtual machine, it uses CentOS. So we have the CentOS operating system, which is based on the Linux. Then we install the HDFS for the file system and install the MapReduce, is the API library for the parallel programming based on Java. Then we can run the Hadoop system. So which means we need to think about the operating system. It's not very critical in this class, in your project, or the research level, but in the production system is very important. Sometimes you need to synchronize such an operating system with other system. Otherwise, even though you compile and the Java program, even though their model is compiled once, running everywhere, which is not true. Even different of the variation of the version, even though you are using the same hardware, same operating system, but it's slightly minor different version that cause the problem. So it's a good idea to synchronize your operating system. Within header system, this is a header system, it's strongly recommended to use same hardware specification, same operating system, same to the minor version, and same application also. Okay? It looks like easy, actually not very easy in real life system. Okay? It's a job of the administrator, but it's very important. Some minor change different cause the huge problem. It's very hard to find such an edge problem. It's not major issue. It's slightly different. It's very hard to find what caused the problem. Okay, so from the beginning, it's a good idea to maintain such a version model. Okay. Even though CentOS, the Red Hat, Ubuntu, all of them are called as the Linux, they are different. Okay, so you need to think about that. For example, CentOS is used for the cloud, okay, and widely used for Hadoop system. Also, Red Hat, the enterprise level Linux is supported. Okay, and also you can use the menu. I believe many of you guys are using the Ubuntu or even Mac OS. So that's okay. But in addition to that, you can use the Fedora Core. Fedora Core is for the cluster. Fedora 12 is about the cluster system. I have used the Fedora Core version 12 to build the PlayStation 3 based parallel system. You can find the poster. Ubuntu also suggested the long-term server. LTS is kind of the it's the production system. Okay, it's already evaluated. Otherwise, it can be the beta version, something like that. Yes.
Also, you said you have installed Fedora on PlayStations.
Yes.
Have you tried to install Hadoop with these PlayStations?
I know. So because the PlayStation, you can use only the 256 megabyte memory. So it's not a good idea to use the PlayStation 3 for memory base.
But it's work, but it's not working.
But ideally, theoretically, you can. As long as you can install that, the operating system, actually you can install the header system. It's not a problem because it uses the Java virtual machine. Okay? But I do not try, I don't recommend. And this is it, and the slides. I think if you are familiar with one of these, the Linux system, there is no problem. But if you never use the Linux system, it's a good idea to during the summer, you spend a little time to get used to using the Linux-based operating system. Sometimes BIOS checking. What is a BIOS?
Basic input output system. Basic input output system.
Basic input output system. Actually, it's the operating system. It's OS. It's operating system. I believe it's the smallest operating system, but it's operating system right away. It's a software, okay, between machine, hardware, and user, client, okay? Hardware, computer itself is a hardware, it's a machine, okay? Nothing but some chip or some wire and a monitor. So you cannot get the benefit of such a computing resource without operating system. So BIOS is the embedded firmware system, your motherboard. Okay? What is the main job of this one?
To boot the operating system.
First, check all the devices. So in motherboard, there might be connected device peripheral, like the monitor, the others, the mouse, keyboard, something like that. Check. And for the master boot record to start main operating system. So this is also very important to have the same BIOS program. Okay, so BIOS has a version even.
It's depending on the hardware,
Yes.
right? So
And also, as we have discussed a lot, input and output I/O speed is very important. That actually the design, the performance of the header, you can even check the speed of your hard disk drive using the HD parameter command. Let me try. What is the speed of the USB 2? 200 megabyte? 150? Something like that. I think that this is the speed of the bus speed. Okay, bus.
Excuse me.
Yes.
So the bias here, as you said in the above of the slides, so it said basic input output system and operating system. In the note, the reference of that note.
This one?
Bias.
Yes.
So it said basic input output operating system.
This is the operating system. Actually, it's kind of operating system, but BIOS is the, you need to purchase the Windows, right? But BIOS was included.
Windows.
Oh yes, it's in your motherboard, hardware. Then it knows where is the master boot record. Master boot record has the location of the image of your operating system. In other words, the process kernel process.
So do we have to do anything specific for the Hadoop for the
The
bias?
simple idea is you need to synchronize all the, okay, in terms of hardware, software, version, and everything. That's a good idea. What is a mount?
you connect the existing operating system. Sometimes use one.
So, file structure, okay? File system has the file structure, okay? There are two types of file structure. One is directory. Directory is also file. And another one is the file. So it looks like this directory structure is good for what? Many file structure. And also you can classify. The hierarchical approach is hierarchical structure is used for directory structure. So you can have, for example, this is a root. Then under the root, you can have, for example, bin, user, and temper, TMP, and for example, data. So if under the bin, you can have the file or another directory structure. In terms of Windows, it's called a folder, okay? Something like that. However, sometimes this is a logical structure still. All file systems are logical structure. I have another directory structure. This one is based on DVHD0 hard disk drive. I have another hard disk drive, DV1. Then it has the user 1, user 2, user 3, and under USR, something like that. So you can mount this one to logical structure. Then this one can be viewed as /data USR user 1, something like that. This is called mount. Okay, you can connect the another file structure to this one. Okay, so you can mount. But if you have the naming node remote side, it can be mounted as network based. It's called the network file system (NFS). Okay, like as if you mount network drive on your Windows. Okay. So you can set up this one. In Unix, ext3 or ext4 file systems are popular, so ext4 are recommended nowadays.